Hi everyone, in this video I'll be going through the last part of chapter 12 worksheet 1 on statistical data handling. Okay, so for this worksheet over here we will be learning about pie charts as well as line graphs. Alright, so you will have seen pie charts in primary school. So this is really just a recap of what we have learned, what you have seen before, and also to understand what are the advantage and disadvantage of using pie charts and how to analyze pie charts when used as a diagram to interpret data. Okay, so you can see over here, what is a pie chart? Essentially, it is a circle which we divide into different sectors. So you can see over here that this whole thing here is a pie chart. I divide a circle into different sectors, and the size of each data set represents the data in proportion to the entire group of data which we are looking at. Okay, so we may spend about 1-2 minutes. Think about what are the advantage and disadvantage of using a pie chart. Once you're done, you can continue playing this video to go through this whether you were right or wrong. Right? Okay, so I hope that you have thought through. So over here, the advantage of using a pie chart is that it is easy to visualize. Easy to visualize. What are we visualizing? We are visualizing the proportion of the part of the pie chart to the whole data set we're looking at. So let's say, for example, over here, if I want to look at pear, I can see that pear takes up the smallest proportion out of all the fruits in this whole circle over here. Okay. And this advantage of using a pie chart is that when I just look at a diagram like this, I only know the proportion. But in this case over here, it is not possible to read the exact frequency, meaning how many people, okay, to read frequency unless the pie chart specify for you. Okay. And also let's say if the question tell you like this whole thing is 100, then you must go and calculate yourself. Like let's say 90 degree out of 360 degree is how many people. Okay, so these are some of the disadvantage of using a pie chart. Alright, so for a pie chart over here, very simply, how do I find the exact number? Is we take the fraction of the angle of this sector out of 360 degree. Because you know that one circle, the total sum of angles is 360 degrees. I find out what angle does this sector take up out of 360 degrees times the total number of items given to you. Okay, so this is one way of how we can calculate pie chart data. Okay, so let's look at the next page over here to help us understand this. Okay, how to construct a pie chart. Okay, so this table here shows us Farhan's expenditure on the holiday. Okay, we have all these different numbers over here. This is how much he spent. So first, we must first find out what is the total expenditure of Farhan. How do I find the total expenditure? I must add all the amount spent. Add up everything together to find the total expenditure. So let's calculate that. If I add up everything, okay, this is 1,000 plus 1,200 plus $400 plus $800 plus $600. Okay, if you add up everything, you should get actually $4,000, and this is the total expenditure of Farhan. Okay, then how do I find the angle then of each sector in the pie chart? Okay, the angle of the sector is the proportional to the amount of expenditure represented by a sector. So for example, let's say I want to do a shopping. Okay, shopping. Farhan spent $1,200. So how do I find the angle? I need to take $1,200 out of the total, which is $4,000. I write out $1,200 out of $4,000 in total. I will times 360 degrees, because one whole circle is 360 degrees. I want to find out if this whole circle 360 degrees represents $4,000. What is the angle that 1,200 take up? I want to find what is this angle. Okay, so I calculate this in your calculator. You should get 108 degrees. Okay, then very simply over here, you will get this to be 108 degrees. You can then easily calculate out what is the other angles in this sector. So for example, food is $1,000 out of total $4,000. I times 360 degrees. I can calculate the angle for this. This one will be equals to 90 degrees. Okay, can I now give you 1 minute? Go and calculate the rest. It should be very simple. Find out what is the angle each of this sector will take in proportion to the whole circle to draw this pie chart. Okay. So pause this video first and continue working out by yourself. Once you're done, continue playing this video to work out the answer. Okay, so over here I'll work out the answer for you as well. Air ticket, 800 out of 4,000 times 360 degrees. Calculate out what this will get. You get 72 degrees. Okay, others is $600 of 4,000 times 360 degrees equals to 54 degrees. And the last one, hotel, is $400. $400 out of $4,000 times 360 degrees, I should get 36 degrees. Okay, so this should be your answers for all the parts over here. And then once you are done with that, you can easily draw out. Let's say, use your protractor and measure 108 degree. Oops, why is that like that? 108 degree, maybe you can look something like this. If this is 108 degree, this whole part here will be for shopping. Okay. Then let's say food, 90 degrees. I draw a right angle, maybe something like this. This is food, 90 degree. Okay. Then I'm sure you can work out the rest by yourself from here. But this is just an example of how we can draw a pie chart using the information given to us. Alright. Let's now look at page number 12, example number 7. Okay. A student councillor board wants to organize a movie marathon for the whole school, so they decide to survey everyone. Each student can only select one choice, and their choice will be represented on a pie chart shown below. Find the value of x. So very simply over here, I know that all the angles in a pie chart add up to 360 degrees. So for example 7a, we can write out. Okay. Example 7a, I add all the angles together. 100 degrees plus 2x degree plus 110 degree plus 3x degree equals to 360 degrees. Okay, so very simply, all you need to do is to then simplify this calculation over here. I combine all my like terms together. My like terms in this case are 100 degrees and 110 degrees on the left side, and also 2x and 3x. So 2x plus 3x is very simply equals to 5x. Okay, 5x, 100 plus 110 gives me 210 equals to 360. Then therefore, to find 5x, I subtract 210 from both sides of the equation. 360 minus 210. 5x will be equals to 150. X will be equals to 30. Okay. It's also good to write the reason for this is why all the angles is because angles at a point add up to 360 degrees. Okay. This is for part A. For part B, hence express the number of students who want to watch Iron Man as a percentage of the whole group of students surveyed. So we look at Iron Man. Iron Man is 2x. Let me highlight here. Iron Man is 2x. So number of students who want to watch Iron Man, we can calculate. Okay. Let me write over here. Okay. Number of students who want to watch Iron Man. Watch Iron Man is equal to 2x. And since I found in part A, x is 30, so this is simply 2 times 30, which is 60 students. In this case here, 60 degrees. Okay. So, I know that over here, this angle here is 60 degree. How do I find this number of students as a percentage of the whole group over here? Very simply, therefore, percentage will be equals to 60 degrees out of 360 degrees times 100%. Okay, and the answer will be 16.667 degree percent. Round off to 3SF will be 16.7%. Rounded off to 3SF. Okay. Alright, and for the last part, if 385 students want to watch Despicable Me, so let's look at the pie chart over here. They are telling me that 110 degrees represent 385 students. Find the total number of students, which is find 360 degree if I know that 110 degree is 385 students. So let's write that down very simply. I know that 110 degree represents 385 students. So this means that to find 1 degree, I have to divide both sides by 110, divide by 110, divide by 110. Okay, so over here, 110, this is 385 divided by 110. 110 students. So to find 360 degree, I will have to then multiply by 360 to find the whole circle, 360 degree. How many students? Times 360. This here to here is times 360 as well. So this is 385 times 110 times 360. The answer to this, you calculate in your calculator, will give me 1260 students. Okay, and with that, we are done with this part of example 7, which is the last part on pie chart. Okay. Okay. Let's now move on to the last statistical data which we will look at, which is the line graphs. Okay, on page number 13. Okay, what is a line graph? You can see over here, this is an example of a line graph. We use line graph to observe whether we have a rising or falling trend in the set of data. So over here you can see that this is a very simple line graph to represent the temperature time graph of a child with fever. So you can see that the horizontal axis represents the time, and this axis represents the temperature of a child. Okay, so let's look at some questions and analyze it together. Okay, horizontal axis here shows the time. How is this different from the other types in the pictogram or other types of bar graph? So the difference is that you see here over here, okay, this quantity is in numbers, whereas in pictograms, the type of fruits is all vary by category, like let's say pear, watermelon, apple. So this is the difference between bar graph as well as a line graph. Okay, quantity is numerical, whereas let's say type of fruits in the pictogram is categorical, meaning that it's sorted by categories. Okay, whereas all the numbers over here is all numerical. Like so you can see the numbers very clearly in the line graph. Okay, and for let's say in a pictogram, the type of fruit, can you change the order very easily? And we go back to the pictogram. You could go back to this pictogram over here. You can see that that's my pictogram. For example, this one here. Do you think I can swap Monday and Tuesday and put Tuesday and Monday? Will this pictogram still work? Or let's say even the fruits here, I swap pear and watermelon. Can I just do that? And the answer is actually yes, because it doesn't really matter for pictogram. In this case over here, so we can therefore write, okay, I'll go back down over here. You can easily change the order. Okay, for pictogram, yes, order does not matter. But if I were to look at this line graph over here, okay, this line graph over here, you can see that is go by time. 8 a.m., 9 a.m., 10 a.m., 11, 12. Can I easily just swap the order like this? And you realize that no, in this case over here, time is sequential, means it is in order. I cannot easily swap the order like that. So I will write down, no, time has to be sequential. Sequential means in order. We cannot change the order from, let's say, 8 a.m., 0800, all the way to 1700. Okay? It must be in sequence. Alright? And also moving on to the next part over here. Okay, the vertical axis of the line graph shows the temperature. How is this quantity different from the frequency axis in the bar graph example number 2? Okay, so you can see over here, right? This line graph, right? This number here, they are asking how is this temperature line graph different from the bar graph example number 2. So I go back to example number 2 to show you. Okay, example number 2, it is, where's my bar graph here? Okay, for example, this, how are the numbers different? Okay, you can see that over here, these numbers are very clear. This is 100, 104, 108, 112. These are all very clear and discrete quantities. Whereas for a line graph, okay, if I go back to my line graph over here, these numbers are actually continuous. Okay, so over here you can see that these numbers range from 0.0 all the way to 0.5, etc. Okay, so over here, if I were to write the explanation down, okay, for a line graph, okay, okay, quantity can be continuous. Oops, let me write that properly. Quantity can be continuous. And for a bar graph, okay, quantity is discrete. Discrete meaning that it's very clear what is the exact number. Okay? And what is the purpose of why do we then use a line graph like that? Because this helps, you can actually see that if I use a line graph like that, it can easily tell me from 8 a.m. all the way to 12 p.m. and all the way to 5 p.m. the trend of the child's temperature over a period of time. So the purpose of using a line graph is that it helps us tell it is used to observe the rising or falling trend or pattern, okay, of the child's temperature over a period of time. Okay. And moving on, another question asks us, okay, we learned previously that frequency bar graph should start from 0. Why doesn't a line graph start from 0? So if I look at this thing over here, okay, why doesn't this line graph start from 0 but it starts from 37? Okay, so why do you think so? If you were to start from 0, you realize that if this one becomes 0, then my line graph, right, let's say 40.0, and then 35, 30, I show you some example. This is the temperature. Okay, 38, 25, 20. Okay, then you realize this data over here will then now look something like this. And if it is something like this, it is too small for us to identify any form of pattern. Okay, and in this case here, we cannot see any trend at all. That is why for a line graph, it is important for us to not start from 0 so that I can expand and make this graph look very clear to me, and I can easily see what is the trend or what is the pattern in the temperature of the child over the time. Okay, so over here, to answer this question over here, okay, if vertical axis starts from 0, it would not be possible to identify a trend. Be possible to identify a trend okay. And for the last two questions over here, Can you tell what temperature at 8:30 is? I look back at the line graph. 8:30. Does it mean that at 8:30 the temperature is 37 in the between 38.0 and 37.5? Answer is no. Okay, from this line graph, all across just means all the data I collected, which means that at 8 a.m., the temperature is 37.5. But at 9 a.m., the temperature is 38.0. This does not mean at 8:30 a.m., the temperature is 37.75. It does not mean that. Okay, I'm only drawing a line to connect all the patterns together, but it could be possible at between 8 a.m. and 9 a.m., the temperature can be any other number, which I will not know. Okay, so over here, we will write, no, we cannot tell. Okay, the temperature of the child maybe it can be any number like 37.4 or even like 37.9 instead of 37.75. Okay, so it's not possible to tell based on this line graph over here, based on the plotted points. Okay, and how is a line graph different from the graph of a linear function? Okay, we know that in a linear function, from what you have learned in chapter 6, okay, the graph of a linear function is always a straight line. But a line graph may not be just a straight line. Okay, you can see over here the line graph usually is very zigzag. The pattern of the graph can be up, down, up, down. It's not necessarily one straight line like this. It may not just be one straight line like this. Okay? Alright, so let's now look at the part 2 over here on page number 15. Okay, moving on from here. Okay, figure 2 shows a company's share price over a period of 30 days. So you see this is $9. Oops, that's my laser. Okay, this is $9, this is $10. So it shows the increase in the price of a share over the period of 30 days. Yihao bought 100 shares on day 1. Okay, and on day 30 he said that he can make a lot of money because the line graph shows a large increase in his value. Do you agree? You can spend 1 minute to think about it and pause this video first. Alright, okay, if you're done thinking, then I'll go through this part over here. Okay, actually, do you agree? Actually, the answer is actually no. Why? Because of this line graph, it doesn't start from 0. Even though here look like, wow, increased a lot, right? Actually, from $9 to $10, it only increased by about $1. So over here, we can write, why do I not agree is because the increase in the price of shares is only by about $1. So actually it's not a lot of money. Okay. Then the next question. The question is often, since this vertical axis doesn't start from 0, it can be quite misleading. Why do people still use this kind of line graph whereby the axis here doesn't start from 0? If you think about it, why do people still use this? Is because sometimes you see in real life, right, the price of shares have very, very small fluctuation. So if I start from 0 here and I put my 9 here, the graph will look something like this. And it's very hard for anyone to examine how is the change in the price over time if I start from 0 over here. So actually, when I start from 9, it helps us to more easily see the change in the price behavior over a period of time. Okay, so over here I'll write, okay, if the vertical axis starts from 0, it will prevent observation of these minor fluctuations, meaning how the graph is changing over a period of time. Okay. Alright. Okay, so over here, I hope you can see that through the use of this data over here, we can see that there are a lot of different kinds of data, numerical data and categorical data. For a line graph, we are using numerical data to display, to use a line graph to display numerical data. Whereas for categorical data, like we use pictogram, bar chart, pie charts to represent data that can be sorted by different categories. Okay, so over here, I'll leave you to read what are the advantage and disadvantage of using a line graph to represent data. Alright, so you read through this different advantage and disadvantage by yourself, because I think it is quite clear from what the discussion which we have gone through earlier. Alright, let's now look at some questions on how we can apply line graph in real life by analyzing the data. Okay, I'm given a line graph over here that analyzes the number of crime cases each year. Okay, so in which year was the number of crime cases the highest? Very simply, just look at your data. The highest point here will be 2015. So answer for this question is very simply 2015. Okay, next part. Find the percentage decrease in the crime case from 2012 to 2013. Analyze my graph. 2012, I have 31,000 crime cases. 2013, I have, over here I read, actually the dot here is in between, is actually over here. I will draw a dotted line to help you see. Okay, actually the dot falls somewhere over here. Okay, and this number here will be about 29,900. Okay, because each box is about 200. So over here, I can easily therefore determine. Okay, 2012, I have 31,000 cases. 2013, 2013, I have 29,900 cases. Therefore, percentage decrease will be equals to 31,000 minus away 29,900 over the original amount, 31,000 times 100%. Okay, this is the formula for percentage decrease. Your final answer should be 3.5484%. I round off to 3SF, I should get 3.55%. Okay, and this is rounded off to 3SF. Alright, so this is just how you can use read line graph based on the information given to you. Once you're done, please go back and complete workbook 1B, question 135 plus question 478 as your homework. Okay, and also for the last part of this worksheet as well, we have gone through all these different types of statistical data analysis. I want you to go and consolidate all the advantage and disadvantage of using these different types of diagrams, which we have gone through earlier. Then also go back and complete these assignment questions on your workbook as well. Okay, you will collect this homework the next lesson we see you. Alright. Okay, so that's all for this whole chapter. I hope that the series of videos have helped you to visualize and understand why we use different statistical diagrams for different kinds of data, and also to know the advantage and disadvantage of using different kinds of data to represent different types of data. Alright, and that will be the end of this video.